is related rates? In differential calculus, related rates problems include two or more related quantities that are changing at the same time, possibly at different rates. We can figure out how fast the quantity is changing over the time if we know how fast the other related quantity is changing with respect to time. This is normally involve writing an equation of two related quantities and solving it by using derivative of an equation with respect to time. For example, we assume that this is a spherical shape of balloon. When the balloon is filled with air, it will increase the radius and volume of the balloon. So we can see that the rate of change in the volume V is related to the rate of change in the radius R. In this case, dV over dt and dr over dt are related rates because V is related to R.
Have you ever think that you can calculate how fast the water can change over the time when you pour the water into the glass? So here the problem statement that we choose to solve in this video. Apple juice is poured into a glass at the rate of 15 cm cubic per second, whose bottom radius half the height. How fast will the area of the base be increasing when the height of glass is 10 cm?
In this question, this is the information given and this is what we want to solve. To find dA over dt, first we must know what derivative to use. In this question, the derivative that we use is dA over dV and dV over dt. However, we already know our dV over dt is equal to 15 cm cubed per second. So how to find dA over dV? I know we can find dA over dV by multiply dA over dr with dr over dV. So this is the area and the volume of the glass. Then we can proceed to find the derivative of the area and the volume with the respect to R. Oh, and also don't forget our information earlier about R.
So H equals to 2R. R equals to H over 2. So H equals to 10 cm. R equals to 10 cm divided by 2 equals to 5 cm. And then we use dA over dV equals to dA over dr times dr over dV. We already have dA over dr is equals to 10 pi r and dr over dV equals to 1 over 6 pi r squared. And then we use that equation dA over dV equals to 10 pi r times 1 over 6 pi r squared equals to 5 over 3r. And we need to find dA over dt. What is dA over dt? dA over dt is equals to 5 over 3r times 15 equals to 75 over 3r equals to 25 over r. When r equals to 5 cm, dA over dt is equals to 25 over 5 is equals to 5 cm squared per second.
In conclusion, we can conclude that related rates problem involve many expressions. Some represent quantities, some represent their rates, some are changing and some are constant. It is important to understand all of the expressions so you can assign appropriate values. For example of related rates equation, if the function is y, then the equation became dy over dt equals to dy over dx times dx over dt. But if the equation asks you to find the area, then the equation will be dA over dt equals to dA over dr times dr over dt. The equation relates to the rates that you are looking for and the rates given in the question. Find a rate at which a quantity changes by relating that quantity to other quantities whose rates of changes are known. Beware if you find words like decreasing, inflated, melting, and slips down. At the end of this assignment, our task goal has been achieved, despite the fact that we had to overcome various obstacles in order to complete this assignment. We worked well together. We can explain what derivatives are, why they are needed, and how to address related rates problems. Last but not least, it can be clarified that differentiation principle can be used to solve problems in our daily life.